today when we do law of cosines, yesterday, law of sines is helpful when you have a corresponding side and angle, like angle A and side A, angle B and side B, or angle C and side C. Works real nice. Well, what happens if that doesn't work out? What happens if I have two sides and an oddball angle? Or two angles and an oddball side? You know, what can I do? So we have what's called the law of cosines to help us out with that. Now, since this is going to change a little bit depending on which angle or which side I'm looking for, we have to have these three different expressions. However, they all set up the same way. Whichever one that we have an angle for, we use the other two sides in calculating on this side, and so forth. But for what we're going to do today, our main focus today in this equation is going to be on what angle do I have, because that's going to help me determine which one of the equations I'm going to be using. So for instance, we'll take a look at the first one here and kind of play with it from there. So I've got side A, side B, and angle C. Notice no matchups with sides and angles. So I notice that I have angle C. So basically what I do here is say, okay, if I have angle C, I'm going to be taking the cosine of that degree measure. I'm going to be finding side C. So once I get that, I can just fill in the rest. So I'm going to square the other two sides and take their sum, and then subtract 2 times the product of those sides times the cosine of 58. The nice thing about this is I can jam all of this into the calculator. After I make sure, that I'm in degree mode. Gotta be in degree mode, otherwise you will not get the same answers that I do. So I'm gonna type this in. Now, here's the catch though. That is not side C, because, well, first of all, it wouldn't make much sense. If my other two sides are 11 and 18, the odds of my other side being 235 doesn't make a lot of sense. But then I remember, oh yeah, that's what C squared is. Now, I don't want you clearing it out and just typing in the shorter decimal part that you've rounded. But I just like putting this again on the notes, so if I'm looking back later trying to figure out where'd that C value come from, I can find it. So once I kind of have a feel for this, I need to take the square root of that number in order to be able to find out what C is. So if you're not familiar with getting the square root, at least on the graphing calculators, it's second and x squared. That'll get me the square root. And then if I want this exact value, which is nice, I really do want that, I'll just use second and the negative button to get that prior answer put in there. And I find out that side C is about 15.3 meters. We're going to round to the nearest tenth on our sides. So you're like, okay, so now I got side C. Oh, hey, now I got side C and I got angle C. I can use the law of sines. That's true. So you're like, I get to use both of them in one problem. Yes, you'll never have to use the law of cosines more than once in a problem. But here's the kicker. We need to use the smaller number, the smaller side of my first two in the proportion. Here's why. When we get into rounding, there's going to be a slight difference in answers if you do one and then the other sometimes with these. And we don't want to get it where, well, I got 18.2, well, I got 18.4. Well, I did it. So if we all do it the same way, won't have that as an issue. So when I go to use my law here, I'm going to take the sine of C over side C. And then I'm going to go find my smallest remaining side. So I will be finding angle B next. And now it's back like what we were doing yesterday. I'm just going to cross multiply. I'm going to take the one that doesn't have my B in it first. And then I'm going to divide by whatever's with my sine of B. But notice the sign did not end up in the denominator where I'm dividing it. And I can use the -1 to help remind me, oh yeah, this is an angle. So what I typically do is I go ahead, oops, not 18, is I get my fractions simplified. Then I recognize right away, oh yeah, that wouldn't be an angle measure, that's kind of small. Oh yeah, I have to take the inverse of sine to get that. And like we mentioned yesterday, you could type this all in at once. We'll do that on one of these too, but sometimes that can get a little bit crazy. And then here, again, the book changed up this time and started going to tenths on angles, so I guess I'm going to do the same thing. Go to the nearest tenth here on my angle and go to 37.6. So if you don't see sometime a direction, just assume everything is to tenths unless you're told otherwise. And then once I have that, I got angle C, I've got angle B. I can now easily get angle A by just subtracting the sum of my other two angles from 180. And I've got all three sides and all three angles. So basically all I have to do is be able to recognize that I'd need to use law of cosines right off the bat, and then I'd use law of sines with my smallest remaining side once I did that. But there is no trickery like yesterday where you could possibly get an extra solution or none. It's just straight run with it and go. So on number 2, same idea. My angle they give me is 100, which is B. So I know I'm going to be finding side B. And then again, it's just knowing your form. The sum of the squares of your sides minus 2 times the product of those sides times the cosine of 100. So once I get those plugged in, again, the nice thing about finding a side with these is I don't have to do things in pieces. I can just fire away with all of them. And then I've just got to remember, oh yeah, this is b squared. So I've still got to take the square root of this. Oops, I want to 8 anyway. And again, that's just second x squared to get the radical, and then second negative to get my answer, and b is going to be approximately 19.2 centimeters. So once I get that, then I go to work with my law of sines. So I will do the easy part. Take the sine of my angle that I have and its corresponding side. What's the other fraction going to look like? Nice. The sine of A over 12, because again, there's my smaller remaining side. So I am going to cross multiply, divide by whatever's with my sine of A here, and for those of you that like to go speedy, like we had mentioned once yesterday, I can do this all at once. I can either type this in and then do second sine of the answer, or I can try to get brave and just go ahead and type everything in right off the bat with my inverse and get the angle that way. Either one works. You can get to round to a whole number this time. And then again, the third angle is always the one we wish we'd get because that's the easiest one. If b is 100 and A is 38. If we subtract those from 180, we find out our C value is going to be 42. One last one. I'm going to go down to 4 just so we can get a little more play with the equation here. And always try not to make yourself more work than you need to. Like for instance, notice on 4, it doesn't want us to find everything. It just wants us to find side A. Well, that makes us happy when we see that angle A is what we have here. So if I'm finding side A, I'd have A squared is going to equal, again, the sum of the squares of the other two sides minus 2 times their product times the cosine of my given angle. And then I basically just go into plug and chug mode. And again, that's not my A value yet. I need to take the square root of that. So A looks like it's about 15.1, and we're in pretty good shape with things here. So the law itself isn't too complicated to deal with. I got one more regular example, and then I want to do the story problems on the back. But then we should be in good shape here. So over to the back we go. We are going to tackle number 5, and then we are going to be done looking at, again, we want everything this time. So I see my 42 here, so I'm going to be finding C squared. And again, the sums of the squares minus 2 times the product of my sides times the cosine of my given angle. And now we just get into a big typing run. And again, that would just be my C squared. I only want C. So I find out that's going to be 23.8 meters. And then I'm ready to roll. Corresponding side and angle. We're now off to sines, so don't keep using cosine or that could cause you an issue. Find that smallest remaining side, and we will be locating angle A next, it looks like. So let's see here. 22 times the sine of 42 divided by 23.8. Again, I went back to the other way. Oh yeah, I forgot to do the second sine already, so I'll do it now. Get that answer in. So my A would be 38.2 degrees. And then again, to find C, excuse me, B, I already have C. I would just add those two up and subtract them from 180. 3 sides, 3 angles. But when I'm doing the law of cosines, I'm going to end up doing the law of sines as well, so it sort of just stacks up one on the other. But for the first couple of times, you'll probably have to follow the formula and kind of check some things, and after that, it'll just become second nature, and you'll kind of be able to just fly along with everything. So, of course, we have to get a couple of application problems in, because we're going to be getting quite a few of them in come Tuesday. So, today we're at the pool. Got ourselves some lifeguard stations in the shallow and the deep water. And the distance between the stations and the bottom of the slide is known, but the manager wants to find out more about the pool setup. When the lifeguards switch positions, the lifeguard at the deep end swims to the shallow end. How far do they swim? Okay, let's see here. So I'm trying to figure out this. You're like, well, let's see here. What do I know? I don't have a corresponding angle on side because I'm trying to find the side. Here I've got the side, I don't have the angle. Here I've got the side, I don't have the angle. Looks like law of cosines is the way we're going to go. So, x squared is going to equal the sum of the squares of my other two sides minus 2 times their product times the cosine of my given angle. So, back to the calculator we go. And we're going to need the square root of that. So, it looks like it's about 11.3 yards from the deep end, from the deep end to the shallow end. So once I get that set, the other question I'm being asked is if the lifeguard at the deep water station is directly facing the bottom of the slide, what angle does she need to turn in order to face the lifeguard at the shallow end? In other words, what angle do I have right here? That's what I need to know. So I look and I go, okay, well, I have a corresponding side and angle now, so I can use that side and angle. And then here I have the side, but I don't have the angle. And I'm just using theta trying to get some of you used to it. That's just nothing different than using x or y or whatever. But a lot of times when we're doing the trig stuff, when we're talking about angle measures, that's the symbol that we'll use to kind of signify it. So once I get that set up, you're like, yeah, this is getting to be old hand now. Once I get these set up, this is a piece of cake. So 12 sine of 38, because I always use my diagonal first that doesn't have the angle I'm looking for. Divided by 11.3, but again, I want the angle, not just that little decimal. So I end up with about a 40.8 degree angle that the lifeguard would be working with. So same exact stuff as just in the triangle, except we've got a picture to work with. Unless we're not given a picture at all. Ooh. No picture. Okay. Drawing on Friday. Here we go. During a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them, which is not very wide. Jackie skates for 5 meters, and Peter skates for 7. How far apart are the skaters? So once again, I don't have a corresponding side and angle, so I have to use the law of cosines. So I go, okay, so my missing side squared, less will equal the sum of the other side's squares minus 2 times their product times the cosine of my given angle. So one more time, and to let the calculator do the heavy lifting, Now, be cautious because you may look at that at first and think that's reasonable, but you're like, oh yeah, that's still x squared. I gotta square root that still. So they're about 2.5 meters apart, knowing that information that I do. So your job is hanging out right underneath the calculator. That will be, let me get myself straight here. Homework check now will be number 2. So again, we'll be looking at a homework check next week. I'm not sure if it's Wednesday or Thursday yet. It depends. So try that out, see how it's going.